ready to take your FastMCP authentication from local testing to production-grade security. You'll see how to configure encrypted Redis storage for OAuth tokens, environment variables for secrets management, and JWT signing, all while maintaining the same simple Google provider interface. This is the exact pattern for deploying authenticated FastMCP servers that survive restarts and scale across containers.
Import OAuth. From FastMCP, import FastMCP. From FastMCP server auth providers Google, import Google Provider. From key value, AO stores, Redis import Redis store. From key value, AO, wrappers, encryption import Fernet encryption wrapper. From cryptography, Fernet import Fernet. Hash production setup with encrypted persistent token storage. Auth provider equals Google provider. Client ID equals 123,456,789. Apps, Google user content, com. Client secret equals goxpsabc 123. Base URL equals https://yourproductiondomain.com. Required scopes equals OpenEye. https://www.googleps.com/auth/userinfo email. Hash production token management. JWT signing key equals OS. Environ JWT signing key. Client storage equals Fernet encryption wrapper. Key value equals Redis store. Host equals OS. Environ Redis host. Port equals int OS. Environ Redis port. Fernet equals Fernet. OS. Environ storage encryption key. MCP equals FastMCP. Name equals production Google app. Auth equals auth provider.
This implements the OAuth proxy pattern to bridge Google's traditional OAuth 2 flow with FastMCP's authentication requirements. The pattern acts as a translator between external identity providers and your application's internal auth system, handling token exchange, validation, and user context propagation automatically. What makes this distinctive is its ability to maintain stateless security while supporting stateful OAuth flows, using encrypted storage to persist tokens across server restarts. The architecture separates authentication concerns into 3 layers: the provider handling OAuth mechanics, encrypted storage managing token persistence, and the FastMCP server enforcing access control. Google's tokens get validated, then wrapped in JWTs signed with your application key, while Redis with Fernet encryption ensures sensitive data remains secure at rest. This separation lets you swap providers or storage backends without changing your application logic, following the dependency inversion principle. This approach solves the production-grade authentication problem for RPC systems, where you need persistent sessions but can't rely on browser cookies. It's particularly valuable for distributed systems where servers may restart or scale horizontally, as the encrypted Redis store maintains session continuity. The trade-off is operational complexity from managing encryption keys and Redis, but the pattern justifies this by eliminating custom auth code and providing a standardized security model. Let's break it down line by line.
Import OAuth.
Imports Python's OAuth module for environment variable access. This enables secure configuration by pulling sensitive values like API keys and encryption keys from environment variables rather than hard-coding them. Critical for production security and 12-factor app compliance.
From FastMCP, import FastMCP.
This imports FastMCP, the core framework for building AI callable tools. It handles the heavy lifting of exposing Python functions as structured tools for AI models, managing authentication and routing requests.
From FastMCP server auth providers Google, import Google Provider.
This imports Google Provider, FastMCP's OAuth 2 handler for Google Authentication. It manages the OAuth flow, token exchange, and user validation against Google's identity service.
From key value, AO stores, Redis import Redis store.
Imports Redis store, a persistent key value storage backend. This handles token storage across server restarts, replacing volatile in-memory solutions.
From key value, AO, wrappers, encryption import Fernet encryption wrapper.
This imports Fernet encryption wrapper, a transparent encryption layer for stored data. It automatically encrypts all values before storage and decrypts on retrieval, ensuring sensitive tokens remain protected at rest while maintaining normal key value interface usage. The wrapper pattern here keeps encryption logic separate from storage implementation.
From cryptography, Fernet import Fernet.
This imports Fernet from the cryptography library, a symmetric encryption implementation for secure data encryption. It provides the encryption key management needed to securely store OAuth tokens in Redis, preventing unauthorized access to sensitive credentials.
Hash production setup with encrypted persistent token storage. Auth provider equals Google Provider.
This initializes the Google OAuth provider for production authentication. It handles user login via Google, manages token storage, and enforces required permissions through OAuth scopes. The configuration ensures secure, persistent sessions while maintaining strict access control.
Client ID equals 123,456,789. Apps, Googluser content, com.
This is your Google OAuth client identifier, issued from Google Cloud Console. It uniquely identifies your application to Google's auth servers, ensuring proper OAuth flow initiation and token validation. Never commit real credentials to version control.
Client secret equals GOXPSABC 123.
This is the OAuth 2 client secret for Google Authentication. It verifies your application's identity to Google servers, preventing unauthorized access to user data. Never commit this to version control. Use environment variables in production.
Base URL equals https:// your production domain, com.
This sets the canonical base URL for OAuth redirects and API endpoints. Critical for production deployments, it ensures all authentication flows return to your domain and prevents open redirect vulnerabilities.
Required scopes equals open-eyed. https://www.googleepies.com/auth/userinfo email.
This defines OAuth scopes required for Google Authentication. The open-eyed scope enables identity verification, while userinfo, email, grants access to the user's email address, both essential for secure authentication flows. Without these, the provider can't validate users or retrieve necessary profile data.
Hash production token management. JWT signing key equals OS. Environ JWT signing key.
This sets the JWT signing key from environment variables, ensuring secure token generation. Environment variables prevent hard-coding secrets while allowing rotation without code changes, a production security best practice.
Client storage equals Fernet encryption wrapper.
This wraps the Redis store in symmetric encryption using Fernet, ensuring all stored OAuth tokens remain encrypted at rest. The pattern prevents exposure of sensitive credentials even if the Redis database is compromised, while maintaining transparent access for the application. Fernet provides authenticated encryption with built-in integrity checks.
Key value equals Redis store.
This instantiates a Redis store for persistent key value storage. It handles token persistence across server restarts, preventing users from needing to re-authenticate. The Redis backend ensures scalability and shared state in distributed environments.
Host equals OS, environ Redis host.
This pulls the Redis server address from environment variables, not hard-coded values. Environment variables keep production secrets out of source control while allowing different deployments to use different Redis instances.
Port equals int OS, environ Redis port.
Environment variables always return strings, but Redis requires the port as an integer. This conversion handles that type mismatch, preventing connection failures from invalid port formats. This closing parenthesis terminates the Fernet encryption wrapper initialization, completing the production token storage configuration. It finalizes the nested setup, where encrypted Redis storage handles persistent, secure token management for the Google OAuth provider.
Fernet equals Fernet, OS, environ storage encryption key.
This initializes a Fernet symmetric encryption instance using an environment-stored key. It handles all encryption-decryption of sensitive tokens before Redis storage, preventing exposure of plaintext credentials. The key rotation happens via environment variable updates. No code changes needed. This closing parenthesis terminates the Google provider configuration block, finalizing the production-ready authentication setup with encrypted token storage. It's the last piece that enables the subsequent FastMCP instance creation with all security and persistence requirements properly configured. This closing parenthesis finalizes the Google provider configuration. It completes the production-ready auth setup with encrypted token storage, making the provider ready for use in the FastMCP instance.
MCP equals FastMCP. Name equals production Google app. Auth equals auth provider.
This instantiates the FastMCP server with production-ready Google authentication. The auth provider configuration we set up earlier handles secure token storage, encryption, and OAuth flows, while the name parameter identifies this instance for logging and monitoring. This is the entry point where all routes and tools get registered under the configured authentication system. Production-grade OAuth integration. The encrypted Redis storage pattern with Fernet wrapping demonstrates how FastMCP handles persistent, secure token management across distributed deployments while maintaining provider compatibility. Environment variables and encryption wrappers are mandatory for production. Omitting either leaves credentials exposed in source control or storage. This architecture scales from single-server prototypes to multi-node clusters without changing the authentication layer.
The token that never touches memory becomes the most persistent.